question 8. In a class, there are 18 girls and 14 boys. If the teacher selects 2 students at random to attend a party with the principal, what is the probability that the 2 students are the same sex? All right. So these types of questions where you're making 2 selections or there's 2 events happening one after the other, I like to use a tree diagram here. Okay. All right. So the first student could be a girl or a boy, and the second student could be a girl or a boy as well. So there's 4 possible outcomes: girl girl, girl boy, boy girl, or boy boy. All right, now above each branch we'll write the probability. So the total number of students that we're selecting from is 32. Okay, so 18 of the original 32 students are girls, 14 of the original 32 students are boys. Okay, now if a girl is selected, then there's only 31 students left in the class. Okay, and there would only be 17 girls left in the class since a girl has already been selected. There would still be 14 boys in the class. If, however, we go down the other path and a boy is selected first, okay, then it's still true that there's 31 total students left in the class. However, there would only be 13 boys remaining since the first student chosen was already a boy, and there would be all 18 girls remaining to be picked for the second student. Okay, so now what we're going to do is we're going to multiply the probabilities along the branches to figure out the probability of the 4 final outcomes. So the probability of girl and girl, this will be the probability of girl and then boy, this will be the probability of boy and then girl, and this will be the probability of boy and then boy. Okay, let's make a little bit more space here. All right, so 18 over 32 times 17 over 31. 18 over 32 times 14 over 31. 14 over 32 times 18 over 31. And then 14 over 32 times 13 over 31. All right. Okay, so I think we can go ahead and write the answers as decimals. So this is about 0.308. The next one, 18 over 32 times 14 over 31. That's 0.254. I know this is going to be the exact same thing because the numerators are identical and the denominators are identical. Okay, last one, 14 over 32 times 13 over 31. That's going to give us 0.183. All right, now something worth doing, especially with these tree diagrams, is to add up the probabilities at the end. They should add up to 1, and that's just a way of making sure you didn't make any mistakes. Okay, so 308 plus 254 plus 254 plus 183 is 0.999. So, I mean, just some rounding error, but yeah, basically adds up to 1. Okay, so we've basically drawn out the sample space using the tree diagram. Now let's answer the question. Okay, what's the probability that the 2 students are the same sex? So that could be the first outcome, 2 girls, or the last outcome, 2 boys. Okay, so the probability of the 2 students having the same sex are 0.308 plus 0.183, giving us a final answer of 0.491. Hmm. So I guess I'm going to go with A. It's surprising how they made all the answer choices almost the same value, right? It's only a difference of 1/100th between each different choice. Okay. But our work seems to confirm that 49% is the final answer.